We're gonna focus our energy on our logarithms.
I don't want your car, girl.
Oh, stop it. We're focusing on our logarithms. Okay, so he does such a good job of these kind of just basic ideas. We already know what a logarithmic function looks like. So he's drawn it for us there. And then notice, if the A out front is negative, look at what it does to the curve. When you put make the number out front negative, what happens to your picture? It flips across the x-axis. And isn't that exactly what happened in that second picture? So that is a picture of a logarithm with a negative leading coefficient. It's flipped upside down. Notice that the original logarithm function is always increasing, and when you tip it upside down, then it is always decreasing. Notice that the original one is concave down, but when you flip it upside down, it becomes concave up. Okay, so let's look at example 1. Write limit statements for the end behavior of the following logarithmic functions. Now, this is the first thing that's going to be different, because what are we used to doing when we do end behavior for functions? We're used to writing the limit as x approaches infinity and the limit as x approaches negative infinity. Would you agree with that? That's how we do it. But not with logarithms. Would you agree this doesn't make sense for your basic logarithmic function? Because it does not approach negative infinity. What does it approach?
0.
0 from the right. So this is going to be your end behavior for a normal logarithm. Now obviously we start flipping around and all that stuff, moving them, that could change. But for your normal logarithm, remember, it has an asymptote on one side that it's going to approach. So, for problem A, the limit as x approaches 0 is what? I'm looking at example 1, picture A. What's my end behavior on the left? Where's that curve going? Negative infinity. Yep, let's speak up, guys. We should be awake by now. And then what is it on the right side? What's happening that way?
Infinity.
Positive infinity, absolutely. Absolutely. All right, now, can you do B? That's your upside down. Can you do that one? Actually, that's H. Okay, what's happening on the right side of that picture? This is the right side now. What's happening on the right side? Negative infinity. And what's happening on the left side? Positive infinity. Is that okay with everybody? All right, now what about C? There's no picture. There's just the equation. Notice that the coefficient out in front is positive. So which shape are we going to have? Are we going to have a shape like example A or a shape like B? A. So the end behavior for C is going to be exactly the same as the end behavior for A. Would everybody agree with that? These are like logarithms, or they are logarithms. These are like exponentials. Their end behavior is going to be the same. There's only a couple of basic shapes you can have, and that's what's going on here. All right, well that was easy enough. Let's see what's next. For each of the following, determine if the logarithmic function is increasing, decreasing, and what's its kind of average. Okay, A is easy. There's a picture. Increasing or decreasing? Decreasing. Concave up or down? Up. Good. All right, how about D? Concave down and increasing, right? Now, C is no picture. But notice, C has a negative leading coefficient. So which of our pictures, A or B, is C going to look like? A. So it has the same characteristics. So it's going to be decreasing and concave up. I think this is pretty easy. What do you think? Yeah? All right, so let's go back to, let's look at example 3. Here are our charts. Now, it tells me that they are logarithmic. So think about what we talked about last time. Logarithmic means your inputs are doing what? No, not for a logarithm. For a logarithm, your inputs are multiplying and your outputs are adding, right? Keep that straight. It's the opposite of an exponential. So, in the first chart there, first table, my inputs have to be multiplying. So what's K gotta be? 4. Aren't I multiplying by 2? So K is gonna be 4. Now, what about the next chart? The second table there. What is that K
2.
value gonna have to be? It's gonna have to be 2, because aren't we multiplying by 3?
Yeah.
Yep, so to back up, we'll divide by 3 and get 2, very good. All right, do the last 2 on your own. See if you can figure out. Remember, it is logarithmic. What do you think about that third one? Alex is shrugging.
Like, I found a way to do it, I think, but it's probably wrong.
Okay.
Like, they're being multiplied each time, so I was like thinking that 4 times x is equal to 5, and then 5 times x is equal to 7.
Uh-huh.
I just do-
And that would be exactly right, but what happens when you do that? What happens when you solve 4 times x equals 5, okay? What do you get when you solve that?
1.25.
Okay, and then 5 times x is 7,
Yeah.
and that should be 5 times 1.25, shouldn't it?
It's 1.4. It should be, but it doesn't.
Yeah, that's what it should be, but it isn't.
It's 5, but it's 7
So-
divided by 5. For that, like, for
1.4.
that.
Yeah, but 7 divided by 5 is not the same as 5 divided by 4,
So it's not like.
so it's not logarithmic. He tricked you. He tricked you. He made you sweat.
I thought it was
And
stupid.
breathe hard. You did exactly the right thing, Cole. But the fact that those two numbers didn't match
I should have told you
means
it
we're
was.
messed up, yeah. Because if it's logarithmic, those two numbers will match. All right, what about, did you get the last one?
Differences.
E to the 4th? What's going on there? Aren't we multiplying by e cubed? So our ratio, our multiplying number is e cubed, so that would be e to the 4th. All right, one more time, just to make sure. in a logarithmic table of values, the x's are being multiplied by the same number, and the y's are being added by the same number. Okay? Got it? Okay. All right, now example 4, find the domain and range. This is an easy question if you know what your graph looks like. Okay, so let's look at the first one. It's y equals 2 log base 3 of x. Now, don't get all, freaky about the base, okay? Doesn't matter. This is a logarithmic function with a positive coefficient. So of the two graphs at the top of the page, which one is this going to look like? The second one? So it looks like this. Now tell me its domain. What is its domain?
0 to infinity.
0 to infinity. What's its range? Negative infinity to infinity. Don't make it harder than it is. Delilah, head up, sweetie. You feeling okay?
Yeah.
Forward out of your mind. Sorry. Okay, B. Now B has a negative leading coefficient. So which shape does it match with? A? But there's another change. What other change has been made in problem B?
It goes to the right, 3.
We have horizontally translated it. That's a horizontal translation. So it should look like A, but everything's been shifted 3 to the right. So the asymptote isn't at 0 anymore. The asymptote is now at 3. Now it has the same shape, so that part isn't changing. That part isn't changing, but it's been shifted. So what is the domain of this guy?
3 to infinity.
3 to infinity. And remember, you can't include an asymptote. And then its range is still negative to positive infinity, right? Would you buy that? All right, go ahead and do C. Go ahead and do C. See what you can come up with. Think about what the general shape's gonna be, and then think about how you may have moved it.
What x has to equal this whole time is 0. So I need to find out this whole parenthesis is 0. Just so it's equal to 0. Minus 3. That's what we're doing. So now we're going to the left. No, I'm like her. I'm not bringing my guarantee. Oh, I'm right. I guarantee it. No, because I can explain it. Like, it's the whole concept you have to ask me. When it just equals 0. Like when there's no input.
I can't remember if we actually discussed this or not, but it's gonna be huge in Unit 3 when we start doing our trigonometry, so I might as well talk about it now. When you have a parentheses that looks like that, before you do anything, you're going to want to pull that 2 out. Because pulling that 2 out now makes it very clear what transformations have happened. You have moved the whole thing halves to the left. And if you were plotting points, which we aren't, like we don't have a T-chart, but if we did, what would that guy do? Divide all the x's by 2. Now we will be doing trigonometric graphing like this, so those are kind of basics that we already know. But in order to make that determination, you need to pull that 2 out. Whatever that is, you need to pull it out. It's still inside, but it's not inside with the x anymore in the parentheses. Okay? So that's a positive 8. So of my 2 shapes, at the top of the page, it would be a B. Would you agree with that? But it shifted 3 halves to the left. So my domain is now negative 3 halves to infinity. And my range hasn't changed. Even though the y values, if I had a T-chart, the y values would be times by 8. So it would be a lot steeper. That doesn't change the range. The range is still negative infinity to infinity. Does that make sense to you? All right, go to 212, notes 212. We'll come back and do the check for understanding as we have time. But I want to get to the properties of logarithms today. And again, this is total review. You guys did this last year. Look at what they call the product property. Does that look familiar to you? That when you take the logarithm of a product, you add the individual logs. When you take the logarithm of a quotient, you subtract the individual logs. And when you have the logarithm of something to a power, we talked about that even today, the power comes out in front. It becomes a coefficient. So there they are. The properties are all written there. Beautiful examples. Let's look at example 1. Your job is to condense this into a single logarithm. So in other words, what that means is log base 4 of something. 1 logarithm. So what are you gonna put in there? X1. Oh my lord, so easy, so easy. How about the next one? It's gonna be log base 3 of what? What? 5 over z, that's a division. Why is that one a division? Because the logarithms individually were subtracted. And when the individual logarithms are subtracted, the problem comes together as a quotient, as a division. All right, now C is a little bit tricky. What do you think about it? Log base 10 of what? What do you think we're gonna have in there? Take a guess. Al?
Log, x divided by 5z.
X divided by 5z. He is exactly right. Why is it divided by 5 and z? Because they are both being subtracted. It is the same, the problem is the same as if you'd had this. So 5 and z are being multiplied, but they are both being divided. You're divided by the whole thing. Perfect. Okay, what about d? Log base 2 of what? What are you going to put in the parentheses for d? What happened to the x? Did you say x, Owen? I didn't hear you.
Or no, I didn't see that.
Okay. It's going to be a division. Would you agree with that?
Yeah.
What's on top? X cubed? Okay, look in the third box of your properties there. What does an exponent, where does an exponent end up? Out in front as a coefficient, and it works vice versa. So if it's a coefficient, it becomes an exponent. So this is x cubed over what? Oh my. Okay. What about the next one? What do you think's gonna be in that parentheses? I'm gonna have an a squared, and it's gonna be over a b to the fifth,
Full race squared.
and where is the 4 gonna go?
Multiplied to the
Up on the top? Why is that one not in the denominator? Because it's not being subtracted, right? It's being added. Oh. F. You gotta write this as log base 6 of something. I need somebody to get really creative here. Yeah, well,
Can you turn 2 into a log?
you absolutely can. And if I'm gonna make it work in this problem, I'm gonna have to change it into a base 6 log, aren't I?
I don't know how to do that part.
Yeah, you do, think about it. You need the log base 6 of something to be 2. Don't you?
Yeah.
So what's the something?
Hit the loopy loop. 6 to the x equals
What's the something gotta be? 6 to the second is what?
36.
So the log base 6 of 36 is 2. Would everybody agree with that?
Yeah.
So instead of having 2 plus log base 6 of x, I'm gonna rewrite my 2 as the log base 6 of 36. Right? And then I'm adding the log base 6 of x, so when I put it all together, it's gonna be 36x. Hmm?
What's the final?
That's it right there. So, I don't know if you were listening to Cole or not, because I know we often don't, but, just kidding, trying to bring some life into this class.
I have some good
Any
ideas.
number can be changed into a logarithm. Could you change 2, the number 2, into a base 7 logarithm? Sure, it would be log base 7 of 49.
Falling down over here.
All right, example 2, multiple choice. Which one's right?
Darius.
I heard some C's. I agree. C is correct. Would you all agree with that?
Mm-hmm.
All right, example 3. Uh-oh, hard vocabulary. See if we can figure it out. The function is a horizontal dilation of this function. Show that f can be written as a vertical translation where k is constant. All right, I remember that these gave us a little trouble with the exponents. So let's back up and see if we can figure out what this is even saying. What are we even talking about here? The original function is log base, no base, just 10. Okay, is the log of 6x. Now, noticing where that 6 is, would you agree that is a horizontal dilation? Yes, because a coefficient on x impacts x this way. Now, what specifically would that do? It would divide all of your x's by 6. Remember how it does the opposite? Oh no, I see blank stares. Not good right before our semester exam. We have to remember that a coefficient on x multiplies or divides your x coordinates. In this case, well, it always divides, but sometimes that's a fraction, so it ends up multiplying. Okay, now your job is to turn that horizontal dilation into a vertical translation. And it is so easy, because wouldn't you say that these two things are equal? And isn't this just a number? Like you could type log 6 on your calculator. So what are you doing? You're taking the log of x and adding that number to it. Isn't that what a vertical translation is? You take your original function and lift it up, and in this case we would be lifting it up by that much. So what started out as a horizontal dilation, a multiplier on x, becomes a vertical translation, something added or subtracted to the problem. Easy. Cool?
So like they don't mean the same thing anymore?
What do you mean?
Like they do different things to
No,
the function?
no, they're the same picture.
Oh.
If you
But how
graph this
are-
on your calculator and you graph that on your calculator, they would be right on top of each other.
But like how are they different terms then, you know what I mean?
No, they aren't different terms. They look different. They look different in the same way that 6/9 looks different than 2/3.
Wait, but I thought one was a vertical and one was a horizontal.
If you take the set of points and you modify it this way or this way, they individually, like from the table of values, they would be being modified differently, but when you put them all together, they're going to be the same set of points.
Oh. Okay.
And if you don't believe me, type them in on your calculator.
No, I believe
This
it's
is
just
base 10, so it's easy to type in.
it just gets confusing. So many words.
So many words, yeah, but we're not gonna be all on by the words. So what's the constant? This is the constant.
Words.
That's what you would be adding. For example 3 says, find K. There it is, there's your constant. All right, example 4. This is where we really need to get, I guess, a little more comfortable with the change of base formula. So, yesterday, or whatever day that was that we were together, we had problems where you could just type them directly into your calculator. And I said that's okay because that's going to be a multiple choice question and it's going to be fine. It doesn't matter. But to do this next exercise, you really have to understand what's going on. And I went through it with you, but I want to do it again. If we have the log base 4 of 9, I know you can type that in on your calculators. Most of you can anyway. All right? But what I'll type in on my calculator, because I don't have a magic button, I'll type log 9 over log 4. Now, what did I just do? I just changed a base 4 logarithm into a base 10 logarithm. And I did that so that I could type it in on my calculator, because my calculator only does base 10 and base E. So I could do ln 9 over ln 4. I can use whatever base the problem requires. Now, normally, it's base 10 or base E because I'm typing stuff into my calculator. But if somebody said, change this, for some reason, into a base 12 logarithm, it would be log base 12 of 9 over log base 12 of 4. The base is irrelevant. Change it to anything you want. once in a while, in a problem like this, it might be handy to use, oh, let's say, base 9. Because if I used base 9, this would be log base 9 of 9 over log base 9 of 4. Would you agree with that? Now, what's my numerator? 1.
That's cemented.
Okay. So I could make my numerator 1. And so simplify it and have 1 over log base 9 of 4. Or I could use log base 4, and then my denominator would be 1. You can change whatever base you want. So what does that have to do with example 4? Well, let's see. I want f of x to be k times g of x. I gotta figure out a better system here. So let's look at what we've got. Let's not worry too much about where we're going right yet. Let's look at what we've got and figure out how we're gonna rewrite it. So f show that f is the dilation of g by finding k, so that f of x is something times g of x. So I want f of x to be something times g of x. So f of x is would you agree with that? Okay. So what's the something? Well, the something would have to be the log base 4 of x over the log base 9 of x. Would that be right? Well, that's okay, but I really don't think that's good enough, because that's kind of a complicated expression. So I wonder if there's anything we can do with that. What's another way of writing this? Right here. What's another way of writing it? Think about what I just erased. What would be another way of writing that?
4x equals 2, or 4x equals 2. Or I mean,
Well, certainly I could do that, but in terms of logarithms, this would be the log of x over the log of 4. Would you agree with that? And then this would be the log of x over the log of 9.
So many logs.
I know, but are you with me? Are you hanging with me here?
Yes, yes.
Now, let's simplify that. What happens when you invert and multiply that, let's say? What is that going to end up being? Kids, this is a fraction divided by a fraction. So what's going to happen? Keep change flip, yeah?
1 over log of 4 times log of 9, or, yeah, times log of 9 divided by 1.
So basically, isn't it going to become the log of 9 divided by the log of 4? Oh my gosh, guys, come on. Let's see some nodding or something here. These are going to cancel, right?
Yeah.
So we have the log of 9 over the log of 4. Now remember, that's k. Is this a number I could type in and get on my calculator? Some decimal, and that's my k. That's my k. So this is the number, right here. That's the number. Then if you multiplied it times this, you would get this. So here was the given. Let's talk about this one more time. Here is the given. This is what he said he wanted to have happen. He said, I want F to equal K times G. So then we solved for K, just by dividing. Then we took these two and did our change of base on them, simplified, and got the log of 9 over the log of 4.
Could it also be the log, could you simplify that further? Because like, when you multiply or divide a logarithm by another.
Oh, no, be careful, be careful. The property, good question. The property says the log of m over n equals the log of m minus the log of n. That's the property. There is no property for log divided by log.
Okay,
This is log of a quotient,
okay.
okay? Yeah. All right, and then finally, example 5. Which of the following is the same? Another multiple choice, what do you think? Which one is it? I don't think it's D. I don't think it's C either. I think it's A. Because the subtraction turns into a division, and those coefficients are exponents, so it'd be x cubed over y to the 4. Alright? Okay. Now, we'll do one more thing, and then we'll get your exam review things out. Back up a page, and we'll go to the check your understanding. So it is the check your understanding on the back of Lumberjack. Okay, we're on the back of the Lumberjack page, and we're checking our understanding. All right, and I want you to do it with your partner. Notice, no calculator. No calculator. See what you can do. No calculator.
What was that? No, don't worry about it. Don't worry about it. What are you talking about? 2, L, 10, 5, I don't know. I do not know what you're talking about.
Come on, I'm gonna need about 5 minutes to talk about your exam, so let's get going.
Yeah, I know exactly. Huh?
You're definitely on the
Is that what it is? Good boy, man. It's for you are good boy. Because I'm tired of it. He started this evil man. He started calling me that. And then everyone's like, oh, close low, man.
He does it to me.
It's because he's Jordan Belfort. If you're watching mobile, I'll shoot my things. Every time Jordan came to you, like,
Yeah.
I didn't end up having to go back in to
he agreed on who he was going to.
like
Yep.
probably a few days. That is such a good
I'm not sure how
wall,
good
man.
it is.
And you married.
Snitch.
But they're done cutting it out.
Yeah. He's getting the
That's what my kinsman
I don't mess around.
So
Thanks for letting me know.
it's not about the money, it's about the roles.
No, that's wrong.
Tell him, when you talk to him,
Correct.
tell him truly I
Tell him
have
to
written
go
for
for
him.
I told him.
What about
I
it?
told him. The fact that that's just not you.
I would say
I'm
not alluded to.
Hey, stop it! What is going on with you two?
Cole's throwing accusations.
Stop it, Cole, and stop, just ignore him.
Talk about accusations. I didn't.
Stop, shut up.
The baker. Like a married girl.
Okay, my friends. What did you decide about the picture here? I hope you didn't make it worse than it is. You know what a logarithm looks like, right? This is what a logarithm looks like, okay? What happens to anything when you change the sign on x? It reflects it
Off the X.
across the y-axis, right? So I hope your picture looks like this. Because it's this flipped, right? So where is your vertical asymptote? 0, x equals 0. It didn't move. How do you move your vertical asymptote? You add or subtract to x. We didn't, so it's still 0. My x-intercept, which under normal circumstances, think your BFFs, is at 1, 0, is now at negative 1, 0, because it got flipped over. My domain has changed because now I'm on the left side of the grid. So my domain is negative infinity to 0. But my range hasn't changed. It's still negative infinity to infinity. Is everybody all good on that? See, there's review built right into that question. Okay. Now, match the following with the graph. No calculator. So look at the first A, picture A. Or not picture A, look at equation, the first equation. Okay, the first equation. It has a negative coefficient. So you remember what those look like, right? Those are the decreasing ones. So I think that is D, picture D. Now look at the second equation. It's just a regular logarithm, so it is equation C. All right, now y, it's starting to get tricky here. What's happening, I mean not y, the third one. What's happening in that middle equation? Right 5. Do I have one that went right 5? A, all right, that's A. And then the fourth equation got flipped upside down, so it's decreasing, and it got picked up 5. So which one is decreasing and picked up 5? B, picture B. And then that leaves E for the last one. Does that make sense? It's a normal logarithm down 5? That makes sense. All right, last one. Write an equation for the logarithmic function that has a vertical asymptote at 5. Stop right there. What do I know about my equation if it has a vertical asymptote at 5? Y equals log x minus 5. Okay? Now, it has to go through the point 11, comma 1, which means what? When I put 11 in there, I have to get 1? Well, that says the log base something of 6 is 1. What does that have to be?
6.
Doesn't that have to be 6? So your equation is y equals log base 6, x minus 5. Alright, so now I'm gonna give you the exam review, which you got homework still to do. I just wanna get this in your hands. So this is a lot of problems. What I did was I went through every piece of the units we've done so far. So 1, 1, 1, 2, 1, 3, and I wrote down at least 3 problems, key problems from each of those. So they're packed in here. After a while, in a few days, I will put in the answers. Right now, the answers aren't there.
I'm not telling you.
Because I want you to spend some time reviewing. We have one more thing of notes to do, one more little bit of notes, and then we will devote our time.
It is tinier than it should be, because I remember it being full.
You have the next 2 homeworks, what is it? 10 and 11, what did you just read today? 11 and 12? So 11 and 12 are due on Thursday.
Why did this?
That's the next thing. Okay? So now what I'm giving you
Possibly the easiest person to read.
is the exact
Shut up.
sheet for the free response questions on the exam. This is the exact thing, you're gonna get this on exam day for the free response questions. Because I wanna make sure that you are all clear on the expectation. Doing the whole AP mathematics thing is new to everybody, all of you. So I've been a little bit fuzzy on some stuff, not on the exam. The exam is gonna be graded exactly like the May 13th exam is gonna be graded. And it's gonna look just like it. You're gonna have some multiple choice, you're gonna have multiple choice calculator, multiple choice no calculator. You're gonna have free response no calculator, free response with calculator. Yeah, this is the instructions for the free response with calculator. They're very detailed, very explicit. Show all your work. Kellen O'Brien,
My bad.
show all your work.
I
So
didn't show my
I
work most
get
of the
that
time.
many of you are bright. So you can look at the problem and say, well, I'm not exactly sure, but I think the answer's 5.
Good boy.
You get no points for that. Multiple choice, great. But not on this. All your work has to be shown. Now, can your work be different than any work we've ever done? Absolutely. As long as it makes sense. Mathematically, it's all good. But you have to show your work. You have an allotted amount of space. So I don't want you to get too carried away, because nothing gets graded outside the space. But they give you ample space. So be as clear as you possibly can. Write more than you think you need to.
On the actual exam, will the FRQ be on paper?
Well, what?
The free response questions, will they be on paper?
Yes, they'll be on colored paper. All the calculator work will be on colored paper. All the no calculator work will be on white paper.
Like on your work, like if you just skip a couple steps, like in between or something.
It has to be clear, and that is in the judgment of the grader. So that's why I say it doesn't hurt to show a little more maybe than you think you need to. All right, you are expected to use your graphing calculator. Stop right here. What does that mean? Have it charged, right? And know how to use it. It is an expectation. You aren't going to be able to answer some of the questions without it on the multiple choice and the free response calculator part. So make sure it's charged. Okay? Avoid rounding intermediate computations. You will get points deducted now and in May if you round intermediately. So a free response question on the AP exam will have many parts to it. Part A, Part B, Part C, using Part B, blah, 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 blah. All these parts. you have to make sure that you are not rounding in all those intermediate steps. So what do? Well, most of you can just click up and pull an answer down on the newer calculators, but you always have a memory. You can store, call it A, and then you can store, call it B. And then in step C, if you need to multiply A and B, you just pull them back out. I want to multiply A and B. All right, if you don't know how to do that, then that's something maybe office hours or ask a buddy or Google it. It's easy, but no rounding until the end. And then how do we round our answer? Never less than 3 decimal places. Never less than 3. You'll lose points, and that's done. All right, it says use calculator to store. Yep. Shall all work and put all answers in the space provided. Okay. So when you get your exam, these will be the instructions. And then I'm going to give you the exam questions. And then I'm going to give you the exam answer sheet. And on the answer sheet, you will have a full page for each part of the free response to encourage you to write. Don't write gobbledygook, but write what you need to write to get your point. Okay, so we got homeworks due all over the place on Thursday, 211 and 212 review. These are not going to take you very long, so don't sweat it.
Are you moving
Where else would I go?
Is that help?
Well, that's where I self-resource.
Okay.
My name's Cole Watson. I'm in Cole Matthew Watson to you.
Cole Matthew Watson, my name's John Christopher Precal. You got the problem here?
What's happening here?
They're gonna fight after school, 3:30 in the parking lot.
It's not true. This is for key referee.
3:30 in the parking lot.
Yeah, they're scrapping it out.
I could flatten both of you.
I agree. I got my money on this board.
She's gonna put us down.
Whoa.
What's the square root of 37?
Log!
Well, you know what we'll do to determine this, bro? We're gonna pull out a second grade times table. We're gonna pull out a second grade
Rocket
times
math!
table.
No, we should actually do that. Like have a race. It's like 8 times 7, 8 times 4. I
know.
will smoke you. I will
Race on
literally
nitro,
smoke you.
I'm so tough at that, bro.
One year we had a tie in the final math league standing. Like 2 kids had exactly the same score. And I wanted to have, on the day we did the ping pong thing, or Irish 500s. Is that what you do, ping pong?
I think we.
Well, anyway, at Irish 500, I wanted to have a math off where they both got down there and we had the spotlight shining down.
That would be
That'd be
cool.
sick.
And
What would
I'm
they
so
do?
for that.
They just do one question or multiple?
They just like go into octagon.
The reason I asked about tomorrow morning was